Hi viewers, you're welcome to my channel. On today's lesson, I'll be taking you on writing formulae from valencies. Writing a chemical formula has been quite challenging to some students, but at the end of this lesson, it will be simplified to you. You should also know how to write chemical formula without difficulty. Okay, we're looking at the following terms for this topic: valency, oxidation number, and radicals. Let's look at their definition. What is valency? Okay, valency is the combining power of an element. It does not have charge, and it helps us do what? To construct chemical formula. Oxidation number is the charge an atom possesses when it gains or loses an electron. Radical simply means group of atoms that carry charge, and they are reacting as one single unit. Group of atoms that carry charge, and they react as single units. Okay, in this lesson, for you to write chemical formula, you must know the valency of that element. So we're looking at the first 20 elements, maybe in addition to other metals in the periodic table. Elements are arranged in the periodic table according to their what? Increasing atomic number. For the first element, you have hydrogen. Let's look at the diagrammatic representation of hydrogen atom. This hydrogen. Hydrogen has the atomic number of hydrogen is 1. Atomic number and number of protons are the same. So hydrogen has 1. So it means that hydrogen can go into chemical bonding by either accepting one electron to attain a duplet state, or by sharing with this one with another element or with itself. It can swear, it can even do what? Donate this one. So the valency of what? Hydrogen is what? 1. This electronic configuration of hydrogen is what? 1. Remember, for the first 20 elements, this first shell can hold maximum of what? 2 electrons. The first shell can hold maximum of 2 electrons. Second shell can hold maximum of what? 8. Third shell can hold maximum of what? 8. And the fourth one can only hold 2. That's for the first 20 elements. The first 20 elements, first shell can hold maximum of 2. Second shell 8. Third shell 8. Then half cation, which is what? 2. So let's look at the valency of hydrogen. The valency of hydrogen will be what? 1. So remember, valency does not have charge. Alright, so let's look at number 2, helium. Helium has 2 electrons, atomos shell. Valence electrons means total number of electrons in the atomos shell. So this helium is stable. It cannot donate electron. It cannot also do what? Lose the electron. Helium is stable. So anyone in a stable state does not have what? It has what? Zero valency. So helium has acquired what? Duplet state. Remember, some elements want to do what? Every element want to acquire either octet state or duplet state. Hydrogen will go into chemical bonding in order to do what? To acquire duplet state like helium. So helium is stable. The total fraction of helium is what? 2. But it has 2 electrons in the what? Its atomos shell. The first shell 2. So the valence is 0. So let's look at lithium. So the first shell can hold maximum of 2. Remember. Then the second one can hold maximum of 8, but helium is what? 3, 2 inside and 1. So this one is the one, helium can easily lose its electron. So the total configuration of helium is what? 2, the first shell 2. Then the second one has only 1. So it can go into chemical bonding by losing its electron. So the valency of helium is what? Is 1. In terms of oxidation number, remember, the Oscillation number and valency are the same. That's equals to valency plus charge. So you can see that value are the same. So the oscillation number has charge. If this little goes into chemical bond by losing this electron, the valency will be what? 1. The oscillation number will be what? Plus 1. Elements that lose the electron, they have positive what? Oscillation number, positive. Their charge will be positive. Those that accept the electron, their charge is what? Negative. So oscillation number of this lithium will be what? Plus 1. Beryllium is number 4. Number of protons and electrons 4. 1, 2, 3, 4. So its atomic configuration will be what? 2 inside the second shell is 2. So it can easily do what? Lose this electron. For chemical bond, it can lose it. So this 2 is the valency of what? Of the beryllium is 2. Then remember, those that lose the electron, the oscillation number and charge will be plus. So oscillation number of this one will be what? Plus 2. So the boron, number of electrons 5. So its atomic configuration is what? 2, 3. Boron can go into chemical bonding with this electron. So this one, the valency of the boron is what? 3. Carbon 2, 4. Carbon has 4 electrons in its outermost shell. So carbon can go into chemical bonding. It will not lose this electron. The one that has 4 will not lose 4. The other one accept 4. So it goes into chemical bonding by sharing. At times you can use only 2 electrons in the outermost shell to go into chemical bonding. At times you can also use the entire 4 to go into chemical bonding by sharing with another element. So therefore carbon has 2 valencies. 2 valencies. 2, if you use 2, the valency will be 2. You can also use 4. It's number 7, 2, 5. So nitrogen has 5 electrons. 5 electrons in its outermost shell. 5 electrons in its outermost shell. So from 5, element with 5 electrons in its outermost shell, remember, it will be easier for that element to do what? To accept 3. We're going to chemical bonding by accepting 3 to have what? Octet configuration or octet state to be 8 that side so that it will be stable. So it will be difficult for it to lose all the 5, but it will be easier to take what? Lesser energy for it to do what? To accept just 3. So that thing is going to accept. The valency of nitrogen is what? 3. The oscillation number, because you accept 3, accepts 3. Those are the element that accepts electrons is going to have what? Negative charge. Their charge is what? Negative. So oscillation number of nitrogen will be what? -3. Oxygen is number 8. 2, 6. So this one will do what? Accept 2. 2 electrons to have what? Octet configuration to be 8 outside. To have 8 electrons in the outermost shell. So the valency of oxygen is what? 2. What should be the oscillation number? Oscillation number of oxygen will now be what? -2. -2. So let's look at fluorine. So fluorine is number 9, 2, 7. Fluorine has 7 electrons in the outermost shell. So fluorine will be needing 1 electron. We're going to chemical bonding by accepting 1 electron. So fluorine will be what? 1. What should be the oscillation number? -1. I want to state something. Any element that has 1 in its outermost shell, that the valence electron is 1, because the valency oscillation number of that element is what? 1. Those with 2, the valency is what? 2. Those with 3, the valency is what? 3. Then the ones with 4 electrons outside, the valency can either be what? 2 or 4. Then from 5, the valency will be, the oscillation number will be 5 minus 8. So those with 5, the valency will be 3. Those with 6 outside, 2. The ones with 1 is 7, and that is our common share. The valency is what? 1. Okay, look at this. Neon is 10. 2, 8. Because each share is already complete. It has a complete share outside. So you cannot go into chemical bonding. You cannot lose, you cannot accept. So valency is 0. So magnesium, 2. Remember, after the order in filling the first 20 elements is 2, 8, 8, 2. First 20 elements. First share can hold maximum of 2, second share 8. So having completed the 8, we move to the third share, which holds 1 electron, and the valency is what? 1. Magnesium, the same thing. It has 2 outside. The valency of magnesium is 2. Aluminium valency of aluminium is what? 3. Silicon, the cell with carbon that has 4 electrons outside. So the valency could be 2 or 4. Phosphorus, number 15, 2, 8, 5. So the valency is what? 3. Okay, let's look at this. Sulfur has 6 electron atomic share. So the valency is what? 2. Because it needs 2 to complete 8. Chlorine, valency is what? 1. Argon already has a complete share, 8. So the valency, it is stable. It does not have any valency. That valency is 0. Potassium, 2, 8, 8. Having filled the third share 8, we now move to the first share 1. So the valency of potassium is what? 1. Calcium, that's the 20 elements in the periodic table. 2, 8, 8, 2. Then we're going to look at some elements have variable oxidation states. Some elements have variable oxidation states. Elements like what? Phosphorus, nitrogen, sulfur, chlorine have variable oxidation states. Some metals, apart from the metals in the first 20 elements, all the metals in the first 20 elements, they have only 1 oxidation state. For example, calcium is only 2. The valency of calcium is 2. Potassium, just 1 is 1. Aluminium. So that they have only one oxidation state. Iron. So iron, the valency of iron will be what? 2 or 3. Copper, 1, 2. So I have copper 1, copper 2. Iron 2, iron 3. Chromium, 3, 6. Manganese, there's so many of them. Manganese, vanadium, and so forth. So some metals have variable oxidation states. So you have seen them. Okay, having known your valency, let's look at what? Radicals. We have OH minus. Their charges are the what? The valencies. For example, this one is minus. Instead of writing -1, it's something as minus. You know, it's a -1. If you see minus, it means 1. Minus, it just means -1. So this is what? Hydroxide ion. Because of the charge, you have to add ion. This hydroxide ion, this atom here element is saying oxygen and hydrogen, they are reacting as what? As a single unit. So hydroxide ion, the valency is what? 1. The oxidation number will be what? -1. This is triozo. I have 3 oxygen atoms here. So 3 is tri. Ozo is what? Oxygen. Then carbonate. Because this is a negative ion. This was saying this carbon. We now use ATE to end it. We add ATE. So triozo carbonate 4. This is triozo carbonate 4. That 4 there is what? Is the oxidation number of carbon. That 4 is the oxidation number of carbon. I'm going to teach you how to do it, how to find this charge. But eventually I've forgotten what? The charge of this, because this charge is what will help us to write chemical formula. This charge that is here, I will teach you how to find this charge if you have forgotten it. You might not need to memorize it, all this charge, but if you can, good for you. You have something, but if you don't know if you don't know it, there's nothing to worry. I know with time you know all these things. But if you have forgotten the charge, I'll teach you how to calculate it. So the oscillation number of this, valency of this one is 2. Valency of this one, this is hydrogen. We name this one first. Hydrogen triosocarbonate 4. So the valency is what? 1. As you can see, the charge is just minus. This is triosonitrate. Nitrate 5. The charge is what? The valency is 1. This is tetraozo 4. Also you have tetraozo phosphate 5. So the valency is this charge. That is 3. Tetraozo. This is manganese, not magnesium. This is manganese. So tetraozo manganate 7. So the charge is 1. The valency is 1. So this is ammonium ion. It's positively charged. Ammonium ion. So the valency is what? 1. Now what are radicals? What? Some of that's heptaozo dichromate. Heptaozo dichromate 6. So the charge is what? 2. So having known your valencies and radical, let's proceed in writing chemical formula. Write the chemical formulae of the following compounds. Number 1, hydrogen sulfide, aluminium chloride, calcium oxide, magnesium fluoride, and lastly iron 3 oxide. So the sulfide, that is sulfur. Chloride is what? Chlorine. Oxide, that's oxygen. Fluoride is fluorine. Bromide is what? Bromine. If you hear bromide, it means bromine. Bromide, that's what? Bromine. Iodide is what? Iodine. So remember, elements in the same group. Group 1 element, the valency is 1. Group 2 elements, the valency will be 2. Group 3 elements, the valency is 3. Group 4 elements could be what? Either 2 or 4. Remember, they are grouped according to the total number of electrons in its atomos shell. So group 1, 1, group 2, 2, group 3, 4 can either have 2 or 4. Then group 5, 5 minus 8. So group 5 elements, their valency is what? 3. Group 6, the valency is 2. Group 7, their valencies are what? 1. Then group 8, they have 0 valency. That's the noble gases, they are very stable. Let's look at the rules that apply in writing chemical formula. Okay, so number 1 is what? Write the formula of hydrogen sulfide. The rule says write the symbol. Write the symbol for the elements. So number 1, I said write the chemical formula of what? Hydrogen sulfide. Hydrogen. The symbol of hydrogen is what? H. What's the valence of hydrogen? At the table you are given, hydrogen is what? 1. Sulfide is sulfur, right? The symbol. So what's the valency for sulfur? Remember, sulfur is number 16. 2, 8, 6. It needs 2 to be 8. To have an 8 in the atomos shell. So 2 is the valency word for sulfur. I've written the symbol and the valency of that element. The next thing I'm going to do is to do what? Interchange the valency. You must interchange. So interchange the valencies, interchange it. So when you interchange, you have this. Then this number, you write it what? To the right of this hydrogen as what? Subscript. So we're having H subscript 2 and what? So I want to say something. This one, we're going to omit this one because same thing. Anything with 2, I said 1 times 1 is 1. 1 times 2 is 2. So anything times multiplied by 1 is same thing as that thing. So I will omit this thing. So what is going to mean that I have 2 atoms of what? Hydrogen and 1 atom of sulfur, even though it's invisible, it's not showing. Once they see this, it means we have 1 atom of what? Sulfur. So this is the formula of what? Hydrogen sulfide. So number 1, write a symbol for the element with oscillation number. So number 2 is what? Interchange their valency. If you fail to interchange the valencies of this element, you get it wrong. Remember, your formula must be what? 100% accurate. So number 2, let's look at number 2 rule. Aluminium chloride. The symbol for aluminium, right? What's the valency of aluminium? Remember, aluminium is what? 3. Aluminium is number 13. 2, 8, 3. So that 3 is the valency for aluminium. Chloride. The valency for chlorine is what? 1. Interchange it. It's always interchange. Remember, you write the number and subscript. Because it's 1, I'll omit this one. Subscript 3. So this is the formula of what? Aluminium chloride. Sodium oxide. Sodium oxide. Write the symbol for sodium. What's the valency of sodium? Sodium is number 11, 2, 8, 1. So 1 is the valency for sodium. Oxide, that's oxygen. Oxygen, oscillation number of oxygen is always, valency of oxygen is always what? 2. Oscillation number of oxygen is always minus 2. So 2, interchange it. N is subscript 2. This sodium oxide, you can see, it's very simple to write the formula. Or you know your valency and the rules that are applied. So let's have number 4, magnesium fluoride. Magnesium. What's the symbol for magnesium? Valency of magnesium is 2. Fluoride, that's fluorine. And the valency is what? 1. Fluorine is 9. 2, 7. So it needs 1 to be 8. So that valency is what? 1. So interchange. Please don't fail to interchange. So magnesium, remember if you have 1, you omit it. Subscript 2. Use the symbol for what? Magnesium. Chemical formula of what? Magnesium fluoride. Let's look at iron 3 oxide. Iron 3. Remember, I told you that some metals have a variable oxidation number. Variable oxidation number. So if you want to write the first time, iron 3. I thought iron has 2 or 3. So that 3 is the valency for the iron. So put it, the symbol of iron is what? So that 3 there is what? The valency of what? Iron. So iron 3 oxide. Oxygen is always what? 2. Interchange. Interchange. Okay, let me add another chemical formula for this. Let's try the chemical formula for calcium oxide. Calcium is what? 2. That's number 20. So make number 20. Number of electrons 20. 2, 8, 8. 2, 8, 8, 2. So 2 is the valency for what? Calcium. So put this 2. All of oxygen is what? 2. Another rule that says if the valencies are the same, it will cancel out. If the valencies are the same, here calcium is 2, oxygen is 2. So it's going to do what? Cancel it out. So if I cancel it out, it's like saying reduce it to the lowest term. 1. So interchange. It will cancel out. That's what it means. Write it like that. Reduce the lowest term. So it's not the what? CAE. So if the valencies are the same, don't interchange without cancelling out. Don't interchange That force of 4 cancelling out. So if you have, where you have 2, 2, where you have 3, 3, cancel it out. Alright. Carbon 4 was right. What's the symbol for carbon is what? C. So this 4, I thought that carbon exhibit 2 valencies, 2 and 4. So now that's carbon 4 side. This 4 is the valency for what? Carbon. So oxygen is what? 2. Good. If you have a number that can divide, look at this number I have here. 2 can divide what? 4. When you have number that can divide itself, you always reduce it to the lowest term before interchanging. You reduce what? To the lowest term. So 2 divide itself is what? 1. 2 divides 4 is really what? 2. You must reduce to the lowest term before you interchange, if not you get it wrong. So don't forget the rule. Number 1, write the symbol of the element and put the valency. Number 2, interchange it. Where the valencies are the same, cancel it out. If the valency can divide itself, reduce to the lowest term. Can divide itself, that's remainder. Reduce it to the lowest term before interchanging. So we'll now interchange. So the formula for carbon 4 oxide is what? CO2. Okay. So this was we looked at is what? These are what? Binary compound. Let's look at I think chemical formula of what? Polyatomic compounds. Look at it. Write the formula of following compounds: potassium hydroxide, sodium triosocarbonate 4, ammonium sulfide, calcium triosonitrate 5, ammonium tetraosophosphate 5, magnesium hydrogen triosocarbonate 4. When you hear this, they don't say, it's too much. I don't know how to write. No. Once you follow your rules, this is very, very simple. It's very, very simple. Okay, let's start from number 1. Sodium hydroxide. So you put the symbol for sodium. The valency is 1. Then hydroxide ion, the charge is what? Is -1. So they are the same thing. They are the same. You interchange. So the formula of sodium hydroxide is what? And if it's 1, remember to omit it. Number 2, the formula of sodium triosocarbonate 4. So the first symbol for sodium is what? And then write the valency of sodium is 1. Triosocarbonate 4. Carbonate as carbon. Trioso, 3 oxygen atoms. Then there's a charge that this radical has. There's a charge it has. If you have forgotten it, there's a simple calculation you can do to get this charge. But if you know it, if you know it's okay, CO3 2 minus, you just put the charge here. Sum of oxidation number is equals to the charge. Then we call the charge X. It's equals to what? The charge. Sum of oxidation number is equals to the charge. If I calculate the sum of oxidation number of this compound, I'll be getting 0 because there's no charge. The compound doesn't have any charge. So sum of oxidation number, that 4, triosocarbonate 4, that 4 is the oxidation number of what? Carbon. So I have 1 atom of carbon. So 1 times oxidation number of carbon, which is +4. Plus, remember it says sum, so plus 3 atoms of oxygen is what I have here. 3. What is the oxidation number of oxygen? It's always -2, except in peroxide. Always -2. This is oxide ion. This is an oxide ion. This is a peroxide ion. So you can see this oxide. That's why oxidation number of oxygen is what? -2. Remember to accept 2 electrons to the octet, to attain octet configuration, octet state. So this oxide ion is what? Peroxide. So in peroxide ion, that oxidation number of oxygen will be what? Will be -1. So oxidation number of oxygen is always -2. Equals the charge. I'm looking for the charge. 4 minus 6. 3 times -2 is -6. -6 times this plus is -6. So 4 minus 6 will give me what? -2. So the charge is -2. So what do? Don't put the charge on the radical. That charge that's supposed to be here is not the valency. So I put what? 2. So remember to interchange. We always do what? Interchange. So the formula will now be what? Remember the 2 is subscript. So this is the formula of what? Sodium triosocarbonate 4. Let's look at the third one, ammonium sulfide. Ammonium sulfide. Ammonium sulfide. Right to ammonium ion. The charge is plus. That plus is what? That's 1. Sulfide is coming from what? Sulfur. Remember, sulfur is 16. 286. So the valency of sulfur will be 2. It needs 2 to obtain octet of donation. So that's 2. Interchange. Remember, there's a rule that says if a number that is what? A valency that's more than 2 is coming to do what? Interchange with a radical. Enclose it in what? In a parenthesis. Enclose it in a bracket. So let's look at this. I will enclose it. Why? Because this valency is 2. If it's 1, I will not use parenthesis to enclose it. If it's 1, I'll write it like that. But because it's 2, I'm going to enclose it and put 2. Subscript 2 outside. Then remember, sulfur is this 1. I'm going to omit it. So this is what? Ammonium sulfide. So let's look at number 3. So number 4. Number 4 is calcium tetraozophosphate 5. Calcium tetraozophosphate 5. You write the symbol of your calcium. What's the valency? Calcium is number 20. 2882. So this 2 is the valency. So valency for calcium is what? 2. Tetraozophosphate. Tetraozophosphate. Phosphate is phosphorus. Tetraozo 4. What is the charge on this thing? If you know what I gave you PO4 3 minus, if you remember that it's 3, you put it. But I've forgotten the charge because if you put any wrong valency, if I put here instead of 3, whatever I've written is wrong. There's something like I heard. She tried, he tried. Your formula must be what? 100% what? Accurate. Right. So remember, you can get the charge if you have forgotten by using sum of oxidation numbers equals to the charge. So tetraozophosphate 5. That 5 is the valency for what? Phosphorus. I have 1 atom of phosphorus here. So 1 times plus 5. Plus I have 4 atoms of what? Oxygen. 4 times the oxidation number of oxygen is always what? Always -2. So I put my -2 here. And what is the charge? I'm looking for it. I call it X. So 5 minus 8. 4 times -2 is 8. -8 times plus is -8. It's equal to my charge. So -3 is the charge. Remember, the charge, you don't put the charge on that radical again. The charge is the valency. So I put what? 3. You interchange it. You interchange. So the formula will now be what? C8 subscript 3. The number must be subscript. If you write it this way, it's wrong. Please don't put it like this. It must be what? Subscript. Remember, this is a radical, and the valency as interchanging to this radical is what? Is more than 1, it's 2. So I must enclose it to what? In parenthesis PO4. So this is what? Calcium tetraozophosphate 5. Okay, let's look at the last one. Magnesium hydrogen triosocarbonate 4. Magnesium. The symbol for magnesium is what? Valency is what? 2. Hydrogen triosocarbonate 4. The charge is what? Is 1. That's minus. Remember, position number of hydrogen is always what? Conventionally. And the position number of hydrogen is always what? +1, except in metallic hydride. In metallic hydride, oxygen exhibits oxidation number of what? -1. That's, look at it. Because all metals have what? Positive oxidation number. So in this case, sodium is what? Plus, hydrogen, that's what? Minus. So it's only in metallic hydride that the oxidation number of what? Hydrogen is what? -1. So this is not the metallic hydride. The oxidation number of hydrogen here is what? +1. So when you do +1, this 4 is for the carbon, triosocarbonate 4. +1 +4 +3 times -2. You'll be getting minus. So this one is minus. Interchange it. Always interchange. So remember, 2 is interchanging with what? The radical. Don't forget to do what? Enclose it to what? In parentheses or in the bracket. So you have what? So this formula of magnesium hydrogen triosocarbonate 4. Let me include one. Let me add additional one for the equation. Potassium heptadichromate 6. So the valence of potassium is what? K. What's the valence? 1. Heptaozo. You see that you have hepta is 7. So heptaozo dichromate. This chromate comes for what? The element chromium. And the symbol is what? Cr. So heptaozo, 7 oxygen atoms, dichromate. So I have dichromate, di equals 2. So what's the charge on this? By the time you do capitalization number of this compound, you'll be getting what? 2. You'll be getting 2. Okay, let's look at it. I have 2 chromium here, 2 chromium atoms. And remember, diisochromate 6. 6 is the oxidation number for chromium. Plus 6. I have 7 atoms of what? Oxygen times the oxidation number of oxygen, which is only -2, equals to the charge. So 2 times 6 is what? 12. 7 times -2 is 14. -14 times plus is 14. So equals to the charge. So you'll be getting -2. So you put that 2 here. But if you know it, you might not need to waste your time getting this. If you know CR207 is -2, you put it, you interchange it. So interchange. You now be having what? K subscript 2 CR2O subscript 7. Question. When you do it, post it in the comment section so I'll see it and commend you. Write the formula for the following compounds: ammonium triazosulfate 4, copper 1 oxide, magnesium tetraozomanganese 7. So when you do it, post let me see your answers in the comment section. Please subscribe to my channel, like and share so that this video can get to more people. Thanks for watching. Have a great day.